Hey Viper Nation, welcome back to another episode of This Week with Cheek. On the last episode, we introduced scientific notation and talked about how incredible it was to be able to reduce the number of zeros in numbers that are really, really big and then numbers that are really, really small. Today, we're going to look at how to use operations in scientific notation. There's multiplication, division, addition, and subtraction. Now in this episode, we're only going to look at multiplication and division. And then we'll use another episode to lay out addition and subtraction. So let's look at our first example. We're going to multiply 2 times 10 to the third by 4 times 10 squared. And so what I teach my students is, first thing we're going to do is multiply the first factors. So the first factor of each term, 2 and 4. That would equal 8. Next, we're going to multiply the powers of 10. And this is why we learned the rules of exponents prior to scientific notation, because we're going to be applying those rules here. This is the product of powers rule. And it says that when you multiply two powers with the same base, such as 10 to the third and 10 squared, you can simply keep the base and add the exponents. So this would give me 10 to the fifth. So now I have my first factor and my second factor. And you always want to make sure that you check to make sure the answer is written in scientific notation. Now I could also convert this to standard notation if I wanted to. This exponent is positive and it tells me to move the decimal 5 places to the right. So right now my decimal is to the right of the 8. So I'll go 1, 2, 3, 4, 5. Fill these gaps in with zeros. And I would have an answer in standard notation of 800,000. Let's go ahead and look at the second example. So here we've got 3 times 10 to the fourth multiplied by 6 times 10 to the third. And this is going to give us a little bit different example. So again, I'm going to multiply the first factors. That would be 3 and 6, also called our coefficients. Next, I want to multiply our powers of 10. So I'm really going to group those terms together. And so we'll get 18 here, and then our product of powers tells us to keep the base and add the exponents. And then in step 3, we want to check to see if that number is written in scientific notation. So, question to you. Is that number written in scientific notation? Think about it. 18 is not between 1 and 10. Remember, our rule of scientific notation says that our first factor has to be greater than or equal to 1, but it's got to be less than 10, and 18 is not less than 10. So what we need to do is need to move our decimal or divide by 10 here to create a number that is between 1 and 10. So right now my decimal is here to the right of the 8. I'm going to move it one place to the left. And mathematically what I'm doing here is I'm dividing 18 by 10. Okay? Now if I divide 18 by 10, I need to balance that out with my second factor. And technically what I'm doing is I'm multiplying that second factor by a power of 10. Okay? So what's going to happen is I'm going to have 1.8 times 10 to the, remember, rule of exponents. If my bases are the same, I keep the base and I add the exponents. So we get 10 to the 8th. Now that number is written in scientific notation, 1.8 times 10 to the 8th. Now, a good rule to remember, if you make this first factor smaller, then you're going to make the exponent bigger by the same factor of 10. If you make the first factor bigger, then you make the exponent smaller. Let's go ahead and take a look at 4 more examples. Now, what I would challenge you to do is pause the video right here, work these 4 examples, and then once you've completed that, turn the page, and I will show you the correct answers. So go ahead and hit the pause button, and then when you finish working, continue play. These are the answers for those 4 practice problems. Good job. Give yourself fist bump. Now let's take a look at 2 examples with dividing numbers written in scientific notation. Very similar. We're going to take the first factor and we're going to divide them. So divide our first 2 factors in each term. So 8 divided by 2. And then I'm going to pair my powers of 10 together. And I want to be able to divide the powers of 10. So 8 divided by 2 is 4. Now, our quotient of powers says that when you divide two powers with the same base, you keep the base and you subtract the exponents. So that should give me 10 to the 4th. So 4 times 10 to the 4th. I'd like to show you again, standard notation, quick note, could also be called decimal notation. If I converted this to standard notation, it would equal 40,000. Let's take a look at our final example, and this one can be tricky, so stay with me. Same steps, we're going to divide our first 2 factors, but as you can already see, 6 does not divide into 8. 8 does not go into 6 evenly. 6 divided by 8. Several different ways you could do this. You could go ahead and just do long division. I would always recommend seeing if the fraction, okay, remember division is simply a ratio or fraction, see if it will simplify. 3/4 simplifies. And then if you need to use long division to get the decimal equivalent, you can. If I were going to use long division, remember our 3 would go inside of the division side and is our dividend, and the 4 would go on the outside. It represents our divisor. Now I know the equivalent of 3/4, and you should too. It's 0.75. 3/4. If you had 3/4 in your pocket, that would be equal to 75 cents, 0.75. Now, our second step is to divide the powers of 10. So we're going to keep the base and then subtract my exponents. 3 minus 8, be careful here, rules of integers. 3 minus 8 gives me 10 to the -5. That's a -5. Step 3, we want to check to make sure that our number is written in scientific notation. So, is our number written in scientific notation? Is that first factor greater than or equal to 1, but less than 10? No, it is not. 0.75 is less than 1. And so, again, we have a situation where we've got to rewrite this number, where we've got to move the decimal. So right now my decimal is here to the left of the 7, and I'm going to move it one place to the right. Mathematically, that means that I am multiplying my first factor by 10, which moves that decimal one place to the right, which means over here I want to divide by a factor of 10. So as to balance the number, to generate an equivalent expression. Now, remember, when we are dividing a power by power, we keep the base and subtract the exponents. So my number, 7.5 times 10, rules of integers, negative 5 minus 1 is negative 6. Now that number is written in scientific notation. My first factor is greater than or equal to 1 and less than 10, and then I have a power of 10 representing my second factor. I do want to show you how to convert this to standard notation. So we take 7.5, negative exponent. That means I'm going to move my decimal to the left. 1, 2, 3, 4, 5, 6. And then fill in these gaps. Also, a reminder. Well, I'm going to write this first. So here's our number. It is proper when writing a decimal to make sure you have a 1 0 to the left of that decimal place. So we would read this as 0.000075. Now, I've also got 4 practice problems for you to work. So again, this would be a great time. Pause the video, work these problems out, just write them down on a sheet of notebook paper, and then when you're ready to check your answers, press play and check those answers, get some feedback. Very important. Here are the answers. I'm going to give you an opportunity to check. You can pause the video now. Hey, great job. Feedback is so important, Knuckles Pig. So hope you've enjoyed this lesson or this episode of This Week with Cheek. Hey, next time we'll take a look at addition and subtraction. See you later.